Hello, deep learners. I'm Andrew Ng, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pine AI what you do at deeplearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Jian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey, Jian. So, do you want to tell the people at Pine AI what you're working on?
Yes, sure. I'm leading a project called Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
You know, the AI field is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pine AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
Hey, everybody. Thank you so much for coming to the event. My name is Dr. Jose Morey. I will be hosting several Pine AI events coming up throughout the year. Thank you so much for registering for the event. Thank you to deeplearning.ai for helping to sponsor the event, as well as Ad Astra Media for the entire team behind this production thus far. Hope you guys enjoy this amazing event and enjoy these amazing women in STEM that we're going to be speaking about regarding AI and radiology. Without further ado, I would like to introduce our speakers. We're going to have two speakers this evening that will be discussing this topic. The first one is Dr. Sonia Gupta. She can wave. She's on the screen now. Dr. Gupta is a physician leader with expertise in healthcare, artificial intelligence, specialty in abdominal CT, MRI, ultrasound, and image-guided procedures. Dr. Gupta had 5 faculty appointments at the Harvard Medical School and Stanford University School of Medicine. Dr. Gupta is medical director of Cure.ai and consults for Google, IBM Watson Health, General Electric, and many others. Dr. Gupta serves on the advisory board for the American Board of Artificial Intelligence in Medicine and today. She is a speaker, educator, and mentor to radiology trainees. Excited about the future of all this. Thank you, Dr. Gupta, for being here this evening. The next speaker that I'd like to introduce is Dr. Judy Wawira, NDMS. She's an assistant professor at the Department of Radiology and Imaging Sciences at Emory University School of Medicine. She's an interventional radiologist specialized in interventional radiology procedures. She's a member of the Cancer Prevention and Control Research Program at Winship Cancer Institute. She holds professional memberships with RSNA, the ACR, SIM, and the American Medical Informatics Association. She's earned her medical degree from Morey University in Kenya. She completed her medical internship at Kiambu District Hospital. And she earned a master's in science and health informatics from Indiana University, Purdue University in Indianapolis, Indiana. In addition, she completed postdoctoral training in informatics at Regenstrief Institute in Indianapolis, Indiana, and a residency in diagnostic radiology at Indiana University. Prior to arriving at Emory, she completed a fellowship in interventional radiology at the Oregon Health Science University in Portland, Oregon. Dr. Judy Wawira, thank you very much for being here this evening as well. So, without further ado, I would like Dr. Sonia Gupta to start off our conference.
Great, thank you, Jose. I'm really excited to be here to discuss artificial intelligence and global health and do an overview for everyone. So these are my disclosures. I'm the medical director of Cure.ai, and I'm a consultant for several artificial intelligence companies and serve on some editorial boards and advisory boards. So the outline of what I want to talk about tonight, I'm really excited to talk about AI and global health and the role it can play. So I want to first start off just talking about low resource hospitals and the unique challenges that they face and the workflow that they have that's different than some higher resource hospitals and how AI can impact that workflow and improve it. And then the real need that some of these places have for artificial intelligence and what role that can play. So just to start off, I want to talk about proper terminology. I was actually an anthropology major in undergrad, and I took a lot of classes about economic development. And, you know, a lot of the classes and the titles and the books we read talked about developing countries and emerging countries. But actually that terminology has fallen out of favor. And the WHO and the United Nations now uses the terminology of low to middle income countries, low resource hospitals, and areas that are medically underserved. So that's been a change in terminology, and I think it's important to kind of know what you're describing when you want to talk about resources and access that patients have to care. So let's just first talk about the global radiologist shortage. I think that, you know, in the United States, where most of us are, or in Canada and Europe, we take it for granted that we have access to physicians in many ways. But there are definitely parts of the world where the ratio of one radiologist to the number of patients that need screening tests and need care is actually 1 to 1 million. I have a really hard time just kind of thinking about wrapping my brain around this because I'm thinking that there is one of me for a potential 1 million patients in many different parts of the world. And if you think about it, each of these patients, it's not that, you know, each of them is going to get one radiology exam in their life. It's actually that each of these million patients is going to have many imaging exams over their life. And so then you have one radiologist for potentially millions and millions of exams that need radiologist subspecialty interpretation. So just as an example, Tanzania has 58 radiologists for 56 potential million patients. And in Mexico, there's 4,000 radiologists for 130 million patients. There's actually 14 countries in Africa that don't have any radiologists at all. So there really is a global radiologist shortage. And when you think about these numbers, if you just compare this to Mass Gen Hospital, for example, in Boston, there's 126 radiologists just in that one hospital in one city that has many other hospitals that also have radiologists. So there really is a shortage around the world for radiologist expertise. And AI can play an important role in helping address that shortage. So what are some of the unique challenges that low to middle income countries have? Well, climate is a big one. So again, we take it for granted. I think most of us know anecdotally, when you walk into a hospital, you immediately feel cold. And why is that? Because the AC is blaring in most hospitals, and it's because our infrastructure and our software and hardware, most of it requires cooler temperatures. So if you think about your CT scanners, your MRIs, if you think about in nuclear medicine, you have radio tracers, they all require climate control. And, it's something that we take for granted is not so easy in some other parts of the world. For example, in Mexico, India, parts of Asia, and sub-Saharan Africa, if there is not consistent access to electricity, they can't necessarily maintain air conditioning or a cool climate where they are. And that has other impacts for IT, software, and hardware that can potentially be damaged. Also, if you don't have consistent electricity, which is a problem in many parts of the world where there are known power outages, sometimes those power outages in parts of India are predictable at certain times of day. But, if they're unpredictable, then that can definitely impact your internet access and access to a cloud where you might be sharing potential patient information. Or if you're right in the middle of a patient getting a scan, they're in the CT scanner, it's moving, and then suddenly there's no backup generator to provide electricity to keep that moving. So these are some of the unique challenges that radiologists and physicians and patients are dealing with in low to middle income resource countries. And then finally, radiologists, as we talked about, there is a global shortage of having enough radiology subspecialty expertise. So what do patients want? And I think this is an important distinction to talk about. This recent article was in the Harvard Business Review in October of last year, and they talked about how they did surveys of patients, asking them if they could choose between artificial intelligence or a human physician, knowing that the AI could outperform a physician, what would they choose? And patients overwhelmingly wanted human physicians. They didn't really feel that they had that trust for AI. And I think it's really important for us as physicians to kind of fill that gap and to educate our patients that no one is really advocating that AI can work alone and be a substitute for physician expertise. And it's really a luxury to even have that discussion because, again, in many parts of the world, there is not a radiologist to replace. So, you'll see on social media and even in the last few years, there have been all these dire predictions about how AI is just going to replace radiologists altogether and we're going to become unnecessary. And I'm a mentor and work with a lot of medical students and residents, and I get messages sometimes on social media asking me if radiology is still a good career for them because they think that they might become replaceable in the future. And, I tell all of them that I don't think radiologists are replaceable, and I don't even think that's really the goal that anyone is advocating for. I think that radiology is still an exciting field to go into, and I think AI is really going to be a tool that helps us do better for our patients and also helps fill the gap in some countries where access to radiology expertise is limited. So factors to consider with AI. We talk about workflow integration and ease of deployment, and those are important factors. And what that really means on a practical level is that integration going to make sense if there are issues with cloud or consistent internet access or infrastructure? And does it require a team to be on the ground? Or could the deployment take 24 to 48 hours versus 6 months? Do you have to have tons and tons of staff available? How easy is it to actually use that AI in the infrastructure that exists? And then local regulatory approval is really important and can't be underemphasized. It's important that there is appropriate clearance, whether it's the FDA or CE marks. It's important to know that the research is there to prove that this AI algorithm is safe to use and it's not being used as an experiment in any way. And you want to make sure that those approvals are based on sufficient quality data sets. So your data sets need to be diverse, and whether that means it's diverse with gender, geographic, ethnic, age, wherever the patients are located, you want to make sure that the algorithm is based on data that is diverse and is applicable in another location and is not centered in one particular region of the United States, for example. And then you have to consider whether you need AI in your workflow because you really do have a shortage of radiologists, or whether you just want AI because it might be a fancy marketing tool for your particular hospital. So, different considerations arise when you talk about using AI in radiologists, and screening is one of them. So radiology plays a really important role in cancer screening, whether it is mammography, lung cancer, colon cancer. That's a really important consideration because all patients need screening and all patients need access to screening. And if there's a way for AI to help with screening, that can really help with efficiency and accessibility. And then you have to think about, do you have an X-ray unit, a CT scanner, or an MRI on site? Again, we take it for granted in higher resource countries that we have access to all of that. But, in many parts of the world, an MRI scanner may not be easily accessible. Patients may have to drive several hours or travel, a full day to get to a CT scanner or an MRI scanner. There may not even be an X-ray unit on site. Maybe they only have ultrasound. The considerations are very different when you consider the resources that are available. And then, is there a radiologist? So let's switch gears and just touch a little bit on COVID-19, since that is the topic that is frequently on everyone's minds right now, as we are in the middle of a pandemic, and how radiology and AI can play a role in COVID-19. So at the beginning of the pandemic, there was a lot of attention, rightly so, directed towards making the diagnosis of coronavirus. And radiology plays an important role in that. And initially, there was a lot of attention about how chest CTs might play a role. And, in Wuhan, initially, there was a large population of patients as they came in. They got chest CTs, and then they also got PCR testing. And so early research did demonstrate that chest CT did have good sensitivity for the diagnosis of COVID-19 when it was compared to the initial PCR test. And, we all know now that the PCR test has a false negative rate of 20 to 30%, and there's many different tests out there. Some of them take an hour to get back, and then others might take 24 to 48 hours to get results back. So I think initially radiology was looked at as a way to potentially provide a diagnosis. However, since then, now we know that the American College of Radiology, at least in the United States, does not recommend routinely using CT of the chest as a substitute for PCR testing. But, despite that, in some other parts of the world, the discussion expanded to what the role of chest x-rays could be and what that role could be in comparison to CTs of the chest. So a lot of research went around at the beginning, gathering these data sets, at the beginning mostly from Wuhan, but then from other sites, using AI to distinguish COVID-19 from community-acquired pneumonia, first on chest CT and then on chest x-rays. And there was some really good, robust data that was published to show that AI could be used to flag patients who might potentially have coronavirus, and that AI could be helpful when a radiologist wasn't immediately available, or if a radiologist was just absolutely overwhelmed by the sheer volume of imaging that was being performed, depending on the hospital. So there is really good data now to show that AI can play a role in helping make that diagnosis, or at the very least, at least flagging patients for that diagnosis. In China right now, there's 34 hospitals that are actually using an AI model that is able to flag patients when they have a chest CT as potentially having coronavirus. And so the way they're using that in practice in these 34 hospitals is when a patient comes in with symptoms, they get a chest CT, the AI flags them as potentially having coronavirus or not having coronavirus. And for the patients that get flagged, those patients immediately get put into isolation and then they get tested. So that's one example of a way in which AI is being used for coronavirus chest CTs. Now, there are some other applications for chest x-rays, and those applications can also involve flagging patients quickly for having low, medium, or high risk for coronavirus. And rationing swabs potentially if there are not enough swabs in a low resource hospital, or potentially checking the progression of patients. So many patients are in ICUs and they're having chest x-rays done, sometimes every 6 hours, sometimes every 12 hours, and radiologists are just getting overwhelmed with the sheer number of x-rays they have to interpret. And so there are some algorithms out there that are able to quantify that and tell the radiologist the exact percentage of how much the coronavirus is spreading in the lungs or whether or not it's getting better. So AI in the era of COVID-19 can play some important roles. We've talked a little bit about triage, a little bit about resource allocation. We again take it for granted that it's easy to get a coronavirus test now and there are enough swabs available. But if you are in a country where swabs are expensive and they have to be rationed potentially, then AI can help with that risk assessment, and then you can potentially preserve those swabs or only use them on patients that get flagged for medium or high risk. And then definitely for volume, if there's just an overwhelming number of chest x-rays potentially being used. AI is also being used for contact tracing, so just kind of outside of imaging. It can be used to provide geographic data of where patients are located, where they've had contacts, and to help isolate their potential contacts and get them tested. So special COVID-19 considerations we've discussed, screening, and then just being well aware of what is available at the individual site, whether it is X-ray or CT, or let's say you have both. And, in the United States, maybe neither is actually that important because, we're just doing a PCR test and watching patients clinically, or they're getting serial x-rays after they've been admitted to the hospital. But most patients in the United States don't really need imaging initially. And then figuring out if the PCR tests are easily available depending on the hospital we're in. And then the cost. So cost is an important consideration because I think that there is this idea that AI is only meant for fancy hospitals with a lot of money. But a lot of AI companies actually now under compassionate use criteria are giving their AI algorithms for free to hospitals to use, or they're giving it to them on a pilot or trial basis. And, it's a mutually beneficial relationship because they're able to gather research and the local physicians at that hospital are also able to use the AI as an adjunct to what they're doing and can potentially use it for research. So it's a mutually beneficial relationship that some companies have been going about using. And then again, if there's a radiologist, what it can do really is if there is one radiologist, or let's say a limited number of radiologists, if the AI can direct their attention to the abnormal chest x-rays and abnormal CTs, that's a huge help. Because then they're not spending their attention looking at normal chest x-rays that may not need their immediate interpretation. So again, for triage assessment, it becomes really helpful. So what are some practical solutions? We've talked about access and infrastructure. I just want to take a moment to discuss Radiate International. They're a nonprofit organization in the United States that's done some amazing work with partnerships for education and to create infrastructure for education for local hospitals. And, just to be clear, when I was first learning about what they're doing with AI, I asked them if they were having any paid partnerships or if they were selling AI to any other countries or anything like that. And it is all non-paid, it's a nonprofit organization. And it's all voluntary. So they're usually using infrastructure to provide education and a platform to help local trainees and local attendings use AI in their model for care for their patients based on what is available to them. And what they really focus on, I'm saying mind the gap, is really to make sure that AI doesn't become a source of a greater gap between high resource countries and low resource countries. And so they're trying to make sure that AI is incorporated in some way so that we don't increase that gap and we can try to actually narrow it and increase access to radiology expertise around the world. So just a moment to talk about the Radiate Friendship Server. I think this is really cool technology. When we talk about infrastructure, temperature, climate control, what can work where, they have a server that's actually compact and it can fit in a small space. It's temperature resistant, so there's no air conditioned room required. It has preloaded software, which simplifies the installation of PACS applications. And it's also able to be carried. So, if there's issues with transportation or a limited number of sites, they can actually bring it with them. And that could save tons of money for deployment. And it's one stop and easy to use. And it can also be connected to the local server with cloud and AI. So this is also particularly exciting. They have a partnership with Google Cloud. And so it can come preloaded with a bunch of clinical applications, and it can also come preloaded with AI applications that are remote on a server. So you can connect your local server to the cloud with the AI, and then you can really increase accessibility for your patients in some more remote areas and lower resource hospitals. So I think that's a really exciting application in talking about using AI around the world. So what's next? You know, we've been talking a lot about FDA clearance and approvals, and, you know, COVID-19 has really become a turning point for AI regulation in healthcare. So in 2018, and actually even in 2019, some of the approvals were a little bit slower, and it took a lot longer to get things approved, and there weren't that many approvals. But now, you know, the FDA approvals and clearances have really sped up, and there's a lot of different products that have come out on the market. Some now have recently gotten FDA clearance for making COVID-19 an incidental finding. So when a patient actually comes in for a CT, let's say of their thoracic spine or their abdomen, and they just get a little bit of the lungs image, and it turns out that they have findings that are suspicious for coronavirus, that AI algorithm can help flag that patient so that a radiologist looks at it more quickly, and they can put the patient in isolation more quickly and get them tested more quickly. So that's a really exciting application that's recently gotten FDA clearance. And there's a whole bunch of them that are just coming through the pipeline. So I think it's a really exciting time for us to think about how we can integrate AI into global health, and also in helping us fight this pandemic and giving us another tool in our arsenal in this rapidly unfolding situation that we're all in. So I want to thank you all for your attention, and thank you, Jose. If there's any questions, you can reach out to me on email or social media, and I think we're going to have a little bit of time for that at the end as well.
Thank you very much, Dr. Gupta. That was excellent. And yes, we will have Q&A at the end for both our phenomenal physicians. So if you have any questions, there's some ongoing dialogue right now through YouTube. If you would like to place your questions there or have some continuous chat there with other people that are watching right now, obviously through other social media channels, both for Dr. Gupta and Sonia and Judy, looking at their social media, you can post some questions through there, or LinkedIn as well. So keep any questions that you have in mind, go ahead and post them, have communication amongst yourself, and we'll be sure to address them at the end of the hour. So now we'll move on to our next speaker, Dr. Gupta, if you would like to go ahead and start your presentation.
Okay, so okay, I hope we can see my slides. So thanks, Jose, for organizing this. Very, very excited to be joining the Payan AI community. And my name is Gichoya. I work at Morey. I'm an interventional radiologist. And also we have a lab called HITI that I co-direct with one of my other physicians called Dr. Fda. And so my disclosures are really not relevant for this presentation, but I am funded by the NSF to look at the future of work for the radiologist and AI. I'm a part of the AI Advisory Council for the American College of Radiology, and I program chair for the RSNA Trainee Editorial Board. And so when this is something that got me into tech for healthcare, and something I truly believe in, which is write code, save lives. And it's just a power when you're a geek that you can actually do good and do, save patients' lives. But I have to caution, that, and I've been in the field for a while, is that not all technology saves lives. And so, so I just want to keep this in mind through my talk. And so I wanted to share this sort of start of Write Code Saves Life, because it's something that I'm passionate about. But also at the end of this talk, if I only could convince one person that they can bring all the smart minds in this community to work on medical AI and medical technology, then that's pretty, that's a big success for myself. And so it will be, you know, not, I mean, this 2020 year has been a beast, if I should say so myself. And, you know, it's hard to imagine that it's hard to imagine that we're just at the middle of the year. This is a picture of a place where I started out actually working in technology, and a very simple messaging, you know, about COVID, right? I like it because anyone on this, even if you don't speak English, you can look at this mural and decide that, okay, I understand sort of what's going on. Masking, hand washing, social distancing. This is how the virus has been sort of drawn, and more hand hygiene. But what I want to sort of talk about has been what has been my experience working in the front lines for COVID. And so, and don't worry, we're gonna come back to AI. And you know, this is my picture when I got my first mask. We know that we really struggled with personal protective equipment in the US. And you can see I labeled it. I have my bag with my, you know, my reusable face shield and my N95 mask. You have to put them there. I still have them. Maybe I've gone through two or three over the last months. And so then there's this concept of, you know, under testing, or we're not reaching everyone that we could be testing. And then, you know, hospitals closed down. We sent away patients who required elective surgeries. And we were honestly afraid. You know, we had this disease that we didn't understand what was going to do. What, you know, we were seeing our friends suffering. And so it was a little bit of, it still is, a little bit of fear and stress and burnout. And then there was this element, especially for my workplace, where we cohorted so that you don't infect everyone if one of you gets sick. So now you've got even a smaller group of people to work with, and remember, there's still social distancing, so you're not seeing everyone else and interacting with them as you would. And so, and then all of a sudden, even the most simple procedures that I do required a new workflow that made it really, really long and very draining, because I was just learning to work in a new workflow. And so if this is not an inspiration to try and do something in this field, I mean, and we're just in the middle of the year, then I'll show you something that is happening over the last 2 days from Houston. I don't know if there are any people watching from Houston, but all of a sudden we're back to, you know, cohorting, trying to figure out how to test, how to scale testing, how to keep patients out of the hospitals and optimize their treatment when they're in the hospital. And so I think that we can all agree that this is the new normal. And so earlier on this year, we wrote an editorial with some of my trainees in the Radiology AI journal, and we said, what's the opportunity of AI for, you know, for COVID, you know? And so obviously, I'm not going to be, you know, talk too much about the use of imaging and testing and the controversies, honestly, around, because I don't think there's consensus around that. But there is agreement that there is a role for monitoring of complications. A few people have come up with various scoring systems. There's a corona score, which is used to enhance, sort of predict what will be the progression. And then we know that there are things, and this has been an argument put out by a lot of people who you know, say that AI can supplement radiologists, where you're just saying the imaging correlates that the human eye cannot see, but these patterns are inherent in the imaging data. That, and we call this a little bit of radiomics and these new biomarkers that you can get from imaging that would be helpful. And could you use some of these biomarkers? Because we, you know, there has been a couple of trials, some recommendations from politicians too in the media, and we really don't know what's the optimum, you know, best choice for what patient. And so I encourage you to spend some time just reading this. It's just sort of like a thought-provoking experience. But I'm going to use this example to focus on something specific, just one area, which is screening. Now, we know that, why is screening important? One, because we know quite a chunk of people are asymptomatic with COVID. And number two, it just helps us to isolate the people who are infected to the people who are disease-free. So reduces the spread, aka social distancing, and, you know, always wear your mask when you're in crowds. And we know that this is, we don't have enough resources in hospitals, and we have to keep patients away unless they absolutely need the care in the hospitals. And even more is that we know that this virus disproportionately affects patients of color, minorities who are already burdened with other diseases. And so, testing them is really a human right. And so also, just not in hospitals, you can decide who's going to get a vaccine. So you can imagine coming up with a killer app for testing. Could AI be used for just testing or optimizing testing? And people are starting to work in this space. These are two examples of models. I'm going to focus specifically on chest X-rays, CoroNet and COVIDNet. One, COVIDNet is a convoluted neural network from Waterloo, Canada, aimed to maximize sensitivity, which is truly pick up all the cases. These are some of the technical factors. I don't want to berate that because you can read the paper and try out the code. Both of them are open source. And then there's CoroNet, which is a two-stage deep learning model from University of Illinois in Chicago, which has a feature extractor as the first step, and then image classification using ResNet 18. And what I just want to show is that look at this accuracy. When you tell me I'm in the midst of a pandemic, and you're telling me I have 93% accuracy, 91% sensitivity, and 93 accuracy and precision of 93%, I'm like, bring this on. And we know that the regulations are getting lax, so definitely an opportunity to integrate some of these AI tools early in clinical care. So we tried this as part of the HITI Lab, and this is the Morey dataset where we have around very almost equal distribution of positive and negative cases. Now here, but if labeling medical imaging is difficult. So one could be just using reports, which is usually the poor man's way or the cheap way to label medical imaging. The next step is you could just use, have radiologists look at the imaging and decide what the diagnosis should be. Now remember, all our sensitivity, whether it's the radiologist or the AI, are really dependent on the burden of disease. If you have never seen, a specific type of diagnosis, you may not be so tuned into sort of your eye pattern picking this up. And also, some of the findings on imaging for AI are pretty non-specific. Now, ground glass opacities can be seen in many things. And so the way we ended up labeling this was to say, if you had this X-ray and you had a positive PCR result within 3 days, we labeled that X-ray as positive. And if you had a negative X-ray, a negative PCR result outside that time span, we label that as negative. And so what's our performance? Pretty disappointing, actually. And so this is not unusual just for this, because we know that AI, when it sees in new data sets, just the performance drops. This is not novel, we know this, but that drop was pretty dramatic, And so now all of a sudden I have an AI tool that I cannot really use, because if I'm a radiologist and I'm having a lot of, false positives, then, I have to check everything just to make sure that I'm not wasteful of resources. And if I'm having a very high number of false negatives, then I'm still having to check through everything to make sure that I'm picking up, all cases and I'm not leaving anyone out. And so what we did actually, and we just sort of released this preprint, is to look at chest X-ray data sets. There are a couple. There's Checks Expert from Stanford, there's the NIH data set, and the MIMIC data set. And this is from Beth Israel in Boston. This is from NIH. And what we know that all these data sets were collected before 2019. And so, as we assume that these data sets have 0 cases of COVID positive cases. And we knew what our data set had. And so we look at the gender distribution and, the race. Obviously, we don't have that data in other places, and just say, because we know that COVID is, a subset of pneumonia, it's a viral pneumonia, and we sort of look at the split for that. And so what we start to see when we look at the performance of this AI on this, now a total of 4 data sets, one that we know this has been our patient, we see a false positive rate of 61% with COVIDNet, And you can see, apart from the chest X-ray, the NIH data set, pretty high false positive rates. If you look at this, we have very high false negative rates. I mean, this is almost like you shouldn't deploy this in real life. Really, not almost. You really should not deploy this in real life, even if the false positive rates are pretty low. And so I just, I don't want to get into the debate, the technical debate of what should we do, what, specifically about this, but I just want to emphasize how difficult doing AI in real life it is. And so it requires a little bit of thinking outside the box and relying on a community that can effectively start to work together to make this point, to sort of make AI that works in real life. So I go back to this and think about what would have changed my life over the last 3 months and what would have been the killer app. Now, we knew that we had PPE shortage. These masks, actually, you have to wear, there's various sizes. I use a small mask, but we know that we have been reusing masks. And we had a lot of people come up and 3D print masks. And so there was still a gap, and there's still a gap between the time that, the fitting that you get, the fit testing, and then the mask that's available. And what if you could get your own personalized mask? After all, we are using these masks. We are finding ways to sterilize them. And what some people started to do is take, this happened in my institution, is to take some sample pictures of what they think the face images are and what those face representations are. And then they moved on and said, okay, we are going to say, if your face looks like this is the mask size you can. This is a grand challenge for the brilliant minds of the Pi and AI community to say, couldn't you take a picture, not for facial recognition, but tell me what's a perfect fitting mask for me? Could you start to generate models so that if Georgia Tech, who are very close to us, where I was and provided some PPE through 3D printing, could make me my mask? When it comes to optimum resource utilization, I think if you're working on this AI, you have to work in the clinical context of where the care is provided. You just cannot think about imaging alone. And this is because, even reiterating through just sort of our experiments, we're starting to learn new things, and we're starting to figure out where can you sort of deploy AI that makes sense. And if you think about being very, very afraid, and why chest X-rays are interesting is because they're easily done. We started to have, I know a few companies have said, well, we're going to accelerate the imaging acquisition. And now you're starting to figure out, are you doing different preprocessing so that I'm not taking all, 100 images when I only need 2 or 3 to help with the diagnosis. And in a place where most of us were paralyzed by fear, some of the things that, thinking outside the box were, I thought of being in Africa, and also how people are starting to use drones to spray farms, and they are very, very selective about the weeds. Now, we were sending our cleaners to do this new style of cleaning the rooms, and all of a sudden I said, why don't we have automated sort of cleaning processes? And honestly, maybe if I could visualize which were the contaminated rooms, at that point my stress would have gone down, because I would have been like, okay, I know. It's just a way of confidence and reassurance, and in this era of team and home cohorting and new workflows, then we're talking about telemedicine, we're talking about new ways of training our future doctors. And so there's just a really big opportunity for AI when you think outside the box. And so I see a big role for robotics. And most importantly, I cannot emphasize on this, it's the essence of Ubuntu, which is working together, because I am because you are. And so thank you. I look forward to an enjoyable discussion for the remaining part of the time.
Excellent. Thank you so much, Judy. That was phenomenal and impassioned, as I was assuming it would be. We've been getting a lot of really great questions. And if we could pull up both of our speakers, I'd like to engage both of them at the same time. Mr. Carlos Gonzalez is in the background. Thank you so much for the help that you've been throughout this process. We'll go ahead and get started. with some of the questions. So I'm going to go back to the very top. This one is from Deeply Product. I'm gonna shoot the questions at both of our speakers. So the first question you can see up on your screen there. Again, thanking one of our speakers, Dr. Gupta, for her amazing discussion. And Deeply Product would love to hear about what are the ethical principles in AI impacting radiology: fairness, transparency, and explainability. Dr. Gupta, why don't you go ahead and start, and then Dr. Kachoya, why don't you give your thoughts on that as well, please?
Yeah, that's a really great question, actually. Thank you for that. I think that's, you bring up a lot of interesting, important points. I think transparency and fairness and explainability are really important. So I think one thing that we sometimes overlook, when everyone talks about data, each one of those data points is a patient. It's an individual patient and it's their images. And I think it's really important that patients are asked if they're okay being a part of an AI research project. I think that their consent to be a part of a project or to give their data is their imaging, their health information to one of these collaborations with an AI company or with researchers is really important. And I think that most institutions recognize that because it's an important ethical principle, because the only reason we're doing this is for our patients, right? We're trying to improve patient care. And so I think we try to be very transparent about, conflicts of interest, industry disclosures, how that affects research. And then I think the important thing is just to educate our patients and to let them know that they have a choice. If they're not comfortable with something, then they don't have to do it. We don't have to use the AI, right?
Judy?
One thing I didn't say is actually I'm a very, 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 very late immigrant. I grew up in Kenya. My family lives in Kenya. And I'm always focused on the last mile. And I think, so especially for global health, there's a little bit of a disparity. And the reason is because most of the regulatory approvals are not even do not exist by the time you're starting to make these products and bring them to life. And so when I spend some time home and I don't talk to my parents about like AI, but I look and they spend some time just seeing when they're sick, how we struggle with getting care. I think for me, it's this new value proposition. And so when I think about some of the models, and it's not about ethical per se that I know what's the right thing or the wrong thing, but I look at something like data ownership. So when my mother is sick, if she was visiting Nairobi, she goes to the hospital in Nairobi. And if she's in my village, she goes to a different hospital. And so all of a sudden, if you're an AI company that says, well, I own this data, and we, as Kenyans, we've always owned our data. You write everything and you give it to the patient because they travel all over the place. And so now when you bring your process and that says, gee, I want to collect all this data because it's valuable, then you're bringing a little bit of, you're shifting the power. And I think most people now are starting to talk about this neocolonialism, where the resources are used, you gather resources and you sort of, the benefit doesn't go back to the sort of like the same people. And so I think in the context of privacy and doing good and also working in an environment where those like regulations may not exist in the first place, I think is extremely, extremely tough for AI and sort of emerging markets. Now in the US, I feel that, people are evolving and, protections are there and there's someone to be sued and all those things. And actually, just to put a plug, this morning we had a very, very good discussion about this ethics of global health AI at the Society of Imaging Informatics, SIIM annual meeting. Where we just talk about the challenges of this. For that specific presentation, I actually randomly hijacked my mom and interviewed her. And I said, what do you think is AI? How much would you pay for AI? Do you think this could go wrong? And she was talking about the same things that Sonia is talking about. What happens when power goes out? All these things, I'm not so sure that they fit into the ethics, but it's just the complexities of where these technologies are deployed. And one last thing I have to say is that we have to realize that this technology is very, very marginalizing for people of color, There's a lot of bias. We know that. We even in medicine, and worse in sort of the criminal justice system. And so we even have to, especially right now with what's going on in the world, we have to be extremely careful to just really be intentional and good about the technologies we build.
Both of those are excellent responses. And what I would ask is, as a follow-up, is there's actually, if everyone that's watching the show tonight looks at the comments, there's a lot of comments and a lot of discussion about inequality or race in AI, or different types of aspects to that you just kind of brought up. Both of you, thank you for that. But my question then would be, what are your thoughts on, this is obviously a very complex issue, right? So what are some solutions or potential solutions? In my mind, I feel like it's going to be multifactorial, from politics to industry and whatnot, and then the actual technology. So in your minds, what do you guys think are some of the potential solutions, or who are the people that need to be at the table having these discussions, and what are some of those conversations that need to be had around this? Judy, why don't you go first, since you went second last time?
Sorry, I was muted. Jose, I think this is a really exciting time, and I'm actually glad that in terms of the AI hype that COVID happened, because I think it reduces the noise, and people who want to do this work will do the work. Right. And so when I see, first of all, we are on the right place by starting to talk to each other, people who are building AI, who are interested in the AI space, like this meetup, because a lot of change is done by just communities. And I can already even see from the questions, some of those technical nuances coming up, And so I think one thing is that we cannot build AI in isolation. We have to think about downstream consequences. We know that there are things that academia is strong in, like data sets. So I specialize my time and our lab generally to do inference and test algorithms. And we know that industry is able to put something to product. They do well with the FDA approval process. And so there's some individual things that we can do. And then the systemic things is coming up with a better way of regulating AI. I don't think we understand that so far at the moment, especially when you regulate AI as a medical device, and you need to update new code, and we all agree that that's changing pretty fast. And then number two is large data sets and for inference and analysis, and then also a little bit of a blame-free culture where you can be okay to get criticism for your work. I'm pretty sure by just showing this work, we will get feedback that's going to make it better and make better product. And so I see just really, and maybe this is really biased for myself because I'm a big open source fan and I work well with communities. And I just believe that there's so many smart minds out there, but we have to sort of get a platform where we unify them and can work together.
Sonia, what do you think?
Yeah, that's an interesting point you bring up, Judy, because I think that is really a problem. There are a lot of people that are kind of working in their individual silos, and they're trying to, they all have the same goal. And so that collaboration, unfortunately, is not always there, sometimes in industry, because, there's profit, hopefully, at the end of the tunnel for some of the companies. So I think, I agree, that's definitely a challenge. Bringing people together and collaborating is really important, especially in the setting of global health and trying to equalize access. And I think that's where nonprofit organizations like Radiate that are forward thinking and, embracing of new technologies such as AI are going to help close that gap, hopefully, and make sure that, we don't make it bigger by having more unequal access to care.
Following up on that Radiate question, Dr. Gupta, there was a question by Joseph Manchenheim that asked what kinds of access or open source kind of access and collaborations is Radiate currently working on their policy towards collaborations?
So they're supposed to be, and they are vendor neutral. So I don't think that there's anything very specific in what they're trying to do aside from just focusing on education. I think that's the major important point that they're trying to do. And before you can get to education about AI, you have to have education about x-rays and ultrasounds and CTs and MRs. And, you know, that's a really large focus, is educating trainees and making sure that they have radiology expertise available. And then, you know, AI would be the next step after that, once that's already been put in place. And then hopefully, you know, increasing that access through education.
Got it. Thank you so much. And I'll try to sum up one last question, because we're coming up at the top of the hour. I want to be respectful both to the audience. Thank you everyone for joining, and both to our phenomenal physicians and their amazing minds. But when we think about inequalities, and we think about the situations that we have going on now and the situations that could be developing with systemic kind of biases that we could put into these technologies, what is the role of technology, if any, in trying to reduce inequalities, as opposed to what is not the role of technology and AI in these kinds of things? How do you guys see that? Where is the right place for it, and where is not the right place for it? Judy, why don't you go ahead and give us your thoughts?
I mean, Jose, this is like content for another another presentation, but I just want to acknowledge, first of all, that there are many amazing people who are doing work in this space. I personally know someone like Tim Nate, and they do not. They get a lot of grief for working on this. You know, they were among the first people who showed the facial bias for the big vendors. You know. The big companies in tech on black skin. And so, but they got shamed for their work. They got, you know, they got questioned. They were real scientists, and much as we're starting to see a moratorium on something like facial recognition, it took a lot of work and a lot of bravery for people to be able to do something like this. And so I just see that the first place we have to really do for medical AI is test and test and test. I don't think we understand what fails and what works. And even when you test in the lab, when you go to the real life, you're just so humbled. I experience this every time, and you cannot stop testing. You have to keep testing and learning, and then sharing. And so there has to be a new language where I can share with my engineers why I think something is failing. It may be very natural for me to share with you, Sonia and Jose, but not very easy for the people who are building the technology. We have to get more heterogeneous data sets, and we have to be humble that the physicians, we don't know the tech as much, and we can learn from other people, and also the tech people, that they're not doctors and can also learn from the doctors. So it requires a very diverse team to build.
Thank you. Sonia?
Yeah, I think, you know, I think the first step is just the recognition that we need to be more inclusive. And I'm optimistic that with AI, we'll have diverse data sets because we're focused on it and trying to make an effort. But I mean, if you think about some medications and vaccines that were developed, you know, 30, 40, 50 years ago, you know, the patient population that they were developing on it was probably mostly men of one race. And, you know, a lot of those early research papers might have had bias. And, you know, a lot of those medications were not, you know, didn't have enough women that they initially tried to use them on in some of these clinical trials. And, you know, that's talking about things that happened, you know, years ago. So the hope is that now, you know, with an increased recognition of the fact that we need to have more inclusive data and more diverse data, you know, not just race, but also gender and age, that we'll be able to get there. And that, you know, that's the goal, that's the hope, right?
Excellent. No, I completely agree. I think we need to have a more serious discussion about these kinds of topics as well. And as Judy just recommended, we might have to do a part 2 with this crew to discuss maybe a little deeper dive into this, because I think it's, if you look at the questions, and obviously for the state of our current union, I think there's a lot to be discussed, and very important, and something that I hope people take away, not just from this talk, but from everything that's going on, is that we need to be continually proactive to try to reduce these kinds of inequalities and not just be reactive to things that are happening, because these things have been happening for literally centuries. And just because they are now popular, I hope this stays with us for generations. And this is something that we continue to try to strive to be better. I mean, that's the best that we can do. But again, Dr. Judy Wawira and Dr. Sonia Gupta, thank you so much, both of you, for being here this evening. I'd like to thank again our sponsor, DeepLearning.ai, as well as AdAstraMedia. And I'd love to thank the team that kind of made this all happen. Miss Erica Jackson, who heads up marketing, Carlos Gonzalez, who has been doing phenomenal work in the background. Please check out his organization, epath.org, doing some phenomenal work and reducing homelessness in California. Our amazing intern, Alexis Peraza, and of course, the guru that runs everything, the director of operations, Miss Lauren Kidd. Thank you very much, all of you, for joining us this evening, and we'll see you guys again very soon, another Pie and I event with myself, Dr. Morey. Take care, everybody. Have a good night.